Okay, guys and ladies, welcome to your first class on symbols and specs overview. So, everybody wants to know, what is it about this class? What's this class about? Well, first of all, it's not a welding class, okay? You're going to need pen and paper. You're also going to need an architectural ruler and pen, paper, and other things, and graph paper, because you'll be doing drawings and stuff like that. So, but let's just talk about the general overview, okay? And there will be a lot of quizzes where you're going to have to draw things. So let's talk about this. So why is this important? So let's say you go into work or somebody says, hey, I want you to build this for me. It's a 3-inch square made out of 3/8" metal. So it's 3/8" from outside edge to outside edge, outside edge to outside edge. So it's a 3-inch square. And they say, okay, go cut the metal for this and let's weld it up. So you have to decide, what size do I cut my side pieces for? 3 inches? That most people would, they would cut everything for 3 inches. Well, that isn't going to work, because you have to remember, you have to account for the metal thickness and the type of weld you're doing to do. Okay, so you have to, in your mind, you have to determine, like, okay, how am I doing this? That's a fillet weld on arrow side and other side. Over here we have a fillet weld on the other side and a butt weld ground flat on the arrow side. Over here we have a V-groove weld. Over here we have a fillet weld on the other side and a bevel weld on the arrow side. And you got this crazy little bend here pointing to this piece right here. So you have to take that and you have to turn it into this in your head. So when you look at this, you go, okay, so the top one here, you can see here, that if you had cut it for 3 inches, you'd been way too long. That piece would have been too big. So you have to take 3 inches minus 3/8 inch here, because it didn't come all the way to the edge, and also 3/8 inch over here. So this piece here is only 2 1/4 inches. Now down here you have 3 inches, and you have to subtract 3/8 for this prep down here. Now this guy here, this edge here, is a full 3 inches, but you'll have to bevel the edges here. Okay, now here on this side, you got one again, 3 inches minus 3/8 up here and 3/8 inch down here. So you're again at 2 1/4 inches. So these are the kind of things that you have when you're putting things together. You have to take into consideration the type of joint it is and the weld that you're going to be putting in there. Okay, so let's take a more detail. So here, this is your first corner here. You had a fillet weld on both sides, arrow side, other side. So you had a fillet weld, other side here, arrow side here. Then we go over here. We have a fillet weld on the other side and a butt weld on the arrow side. And this symbol here is ground flat. So that's why I got ground flat there. Then we go down here and we have a V groove. So you had a V groove on the arrow side right here. We go over here. Now here we have a fillet weld on the other side, but you also have a bevel weld on the arrow side. Now that can be done 2 different ways. You can prep, you can see here, that's a fillet weld there. Same thing here. It just depends on where this line here points to this piece here, means that I am going to modify and prep this side and not that side. Okay, if it was the other way, the arrow would come up and point upward. It would point up that way. So that's why these kind of things, that's why this whole class is important, that you have to think about the joint makeup and the weld you're putting in there. So same thing here. If you're welding this together, you have to know, okay, these are butt welds, fillet welds, butt fillet, and they have sizes assigned to it. So you're going to have to weld to specific size. You go over here. Now here you have another symbol you haven't seen yet. This circle means all the way around. So you have a 3/16 inch fillet weld all the way around that piece there. Same thing up here. But, and here you have a fillet weld and it says ×2. Means you're going to be doing it 2 times. 1, 2. Okay, but we'll be going through more detail on this, but this is just to give you a general overview of why this is an important class for you. Okay, let's say someone said you had this item here you wanted to build or you wanted to make. Well, you can't just give somebody that kind of a picture. So what you give them is something that looks like this. You have the front of the object, the side of the object, the top of the object, and a special picture here for kind of down. It's a different perspective. So when you have a different kind, when something doesn't fall into front, top, side, and you want to go a little more explanation, you get an extra picture here. But so now you could apply sizes to it. And here you see it like this from the front, you have a circle here, and it has the hidden lines from the circle going down through the piece. So you have to be able to take this and come back and basically view so that you know what you're trying to build. Okay, so this is a welding symbol. Okay, a welding symbol has a line, an arrow, and a weld symbol. A weld symbol is a specific item of a welding symbol. But this is the general, everything that you could possibly put into a welding symbol. Okay, so it looks like a lot of stuff here. I mean, there's a lot of things here. A lot of the things you may never ever use, but it's good to know where they are and what they are. So we're also going to talk about joints, different kind of weld joints, butt joints, lap joints, corner joints, T-joints, and edge joints. Okay, these are all the basic welding symbols. Fillet welds, plug, spot, stud, seam, back or backing, surfacing, edge joints, squares, V's, bevels, U's, J's, V-flares. A lot of these you may never see in a real diagram, but they are there for specific reasons. We'll also touch a little bit about metallurgy, about heat affected zones and why heat affects metal certain ways and why you don't want to overheat a metal, and you want to be sure that you're penetrating into, nothing worse than having a weld that looks great, but when you go through when you try to bend it, it breaks apart because it didn't penetrate. The base metal and the weld metal didn't correlate together, didn't merge together. Okay, well, it's just about like what you can see with the heat affected zone when you polish it out and everything. We'll talk a little bit about defects. Like here's your ideal weld, here's cracks, porosity, undercut, slag, spatter, incomplete fusion, incomplete penetration, and overlap. We'll talk a little bit about all these.